Hello, this is the lecture video for REMS 59, 50, 13. So first I'm going to share my screen with you. Hold on a second. Yep. Here is our PowerPoint presentation for this week. Yep, introduction to statistics and research designs. Yeah, so in this first lecture, we will talk about the introduction to statistics and research designs. So like what statistics are and what research designs are. And give you some terms like variables and other things related to statistics in this lecture. So let's just start. This is the outline for this lecture video. So we will talk about two branches of the statistics. I mean the differences in descriptive statistics and, inferential statistics. And also I will identify the different types of variables. So first half of the semester, we will focus on these two things. Statistics and type of variable. And in second half of the semester, we will talk about the hypothesis testing, like here. So today in this lecture, I'm gonna just give you only a brief introduction about all of this. Yep. So here we talk about descriptive and inferential statistics. So statistics allow us to describe particular characteristics of a set of data. They are concerned with the presentation, organization, and summarization of data. So for instance, for 15 students in this class, if I ask everyone their age, then I can get the 15 values, right? This is the age number for those 15 students. So we can consider these 15 different values as statistics. With these statistics, we can make chart, graph, right? And also we can calculate different kinds of the numbers like a mean, median, or a standard deviation. Based on those 15 different values, right? So statistics also allow us to infer our findings to the general population. So we can say our 15 students in this class represent a bigger population of all graduate students in OSU, right? So inferential statistics allow us to generalize from our sample of data to a larger population of subject. So in this our example, those 15 students, I'm gonna just change colors. Yeah, these 15 students are our sample, and The all graduate students in OSU is our population. Yeah, so the statistics allows us to describe specific characteristic of a set of data and also allow us to infer our findings to general population. Yep, this is the descriptive and inferential statistics. So let's talk about a little bit more about the population and samples. Population means who the data is intended to describe. Uh-oh. Describe. Yeah. So the population is a collection of all possible members of a defined group and the group about which we want to draw conclusions. So inferential statistics are those gathered from a sample that very closely represent the population so that conclusions made about the sample can be generalized to the population. And sample means who the data are gathered from. So, the sample is a set of observations drawn from a subset of the population of interest, like a 50 students in our class. And descriptive statistics are used to describe a specific sample. So, samples results are used to estimate the population. So here is one pictures for explaining about the relationship between population and sample. Actually, sample is from our population. And then based on the sample, we can characterize using statistic, specific numbers based on our observations, right? So by using those numbers, um, we just draw inference, estimates, and conclusions about the population. I mean, in order to explain about our population's characteristics. So this is the relationship between population and samples. So by using the sample, we can get descriptive statistic. Mhm. And also by using the sample for drawing conclusion about the populations. Yep, this is the inferential statistics. So here is the example for the population and samples. So across the student campus of OSU, the total enrollment was 24,387 in the fall of 2016. So the university randomly select 1,000 to participate in the sexual violence course. So of those selected, 752 participated for this course. So in this example, what is the sample? Yes, our sample is 752 students who are participated in our the sexual violence course. Actually, we selected the 1,000 of the students, right? But we got the responses from only 752. So our sample is 752, not the 1000. So next question, what is the populations? Yeah, here is really big numbers, right? The total enrollment in the fall of 2016, 24,387 students enrolled at OSU to whom inferences are to be made. So those students are our population. So if you have any questions about the population and samples relationship, yep, you can freely use the discussion board in our Canvas. So for example, if you have any specific research question or hypothesis, you can describe your situation, and this is the population and this is the sample. Is it correct? Something like that. So I can read your situations and identified population and sample, then I'm gonna just make a comment for your specific questions. Yeah, actually this procedure will be really helpful to understand the population and samples. So let's keep going on the different terminology in the statistics. Yeah, so this slide is for the basic terminology in statistics. The first one is a case. A case is an object described by a set of data or the unit of the study. So, for example, automobile, college students, yeah, those are all the case. And when a case, yeah, here is the typo, yeah, case. When a case refers to a human being or a group of people, we call it as subject. Also could refer to an animal, insect, or etc. And the APA preferred terminology when referring to a human being as participant. Yep, so actually those three are actually the same thing. And a variable is any characteristic of a participant or subject or case. So variable can take one different values from case to case, and it's denoted by the capital letter like large X, large Y, yep, and so on. So in this table at the bottom, so how many variables in here? Yeah, we have 5 different variables, right? Section number, males, females, instructor, building. Yeah. And how many cases in here, in this table? Yeah, how many observation? Yeah, here we have 3 rows, right? So we have 3 cases in this situation. So let's talk about a little bit more about the variables. So a variable is an observation or measurement of a characteristic. So variables can take one of a number of values. So here are some examples. Genders, We have two levels generally, male or female, and height, range of the value like a 20 into 90, or eye colors like blue, green, or brown. And maybe we have one more example like a response from 5 Likert scale. I think you guys really are familiar with those, like 1 is strongly disagree, 2 equal disagree, 3 equal neutral, and 4 is agree, and 5 equals strongly agree. Yeah, these are also example of the variable. And in this slide, we can talk about the types of variables. So it is important to know what kinds of variables we're working with. So distinction of kind of variable in a study can be important because it determines type of analysis that should be conducted. So specifically, quantitative variables can either be discrete or they can be continuous variable. First, discrete data have values that take on a fixed number of values, like whole numbers. So it can have only a limited number of values. And the data is observed. So here is the examples. Age in years, number of participants seen in a day. Yeah, those are usually whole number. So except for the infant, yeah, usually we can answer about, yeah, I am 7 years old, 8 years old, something like that. We did not answer 7.8 years, something like that, right? So they're gonna have a fixed number of values. This is a discrete data. And the other one is the continuous one, and continuous data may take an infinite number of values with a defined range. So it often have units and decimals. And data is often measured. So here is the examples: height, weight, time, temperature, blood pressures, right? So for the time, they are infinite value between 30 and 31 minutes, right? Yeah, but still they're gonna have a specific range. So for the quantitative variables, you can have those two types of variable, discrete and continuous. As mentioned before, quantitative variables can be discrete or continuous variable. And there is also 4 other scales of measures. The scales of measures are important since they are just further describe our data. The first one, in the most general, is the nominal scale. Numbers serve as categories or labels and do not indicate any quantitative relationship. Quantitative relationship. Also, there is no ordering. So gender, political affiliation, social security numbers. Yeah, these are the example for the nominal scale. So, for example, there is no any ordering between male and female, or Democrat and Republican, right? And social security numbers are also just a nominal because the numbers do not represent any quantitative values. If we calculate the average of the social security numbers, yep, there is no meaning. That is for just represent a specific, different person, right? So nominal is for the categorical variable. The next one is the ordinal scale. So numbers are for ordered categories, indicating that one is greater than another, but not equal differences. So it indicates rank order. So for example, bars order, Olympic medals, Likert scale when intervals are unequal, and percentile. As I already mentioned, the Likert scale like 1 equals strongly disagree, 2 equals disagree, 3 is neutral, and so on. And for the Olympic medals, gold, silver, and brown, right? Actually, one is greater than others, right? Gold is better than silver, but the difference between gold and silver and difference between silver and bronze may not be equal, right? So the difference between responding 1 and 2 may not be the same as the difference between 2 and 3. And the last one is the example for the percentile. So a person at 5th percentile did not necessarily have a score that was twice that of the person in the 25th percentile. Yeah, actually, for example, we have 20 students, and the highest score of a specific test was 98. So this is the first order. And the next highest score was 96. And the next one is the 80 and 78 and 75. So those are top 5 in our class exam. As you can see, the difference between first and second, and the difference between first and fifth are not equal, right? So the interval is not equal, but definitely first is better than second, and fourth are better than fifth. So this is the ordinal scale. They have ordering, but not equal interval. And we have 2 more. Uh-oh. Yeah. The third one is the interval scale. So we now have numbers, and these numbers serve as scores which are equal distance between each other, and 0 is arbitrary. So the value of 0 does not indicate none of the variable is present. So the best example is the temperature. So in the temperature, 0 degree, does not mean there is no temperature, right? But also the difference between 1 degree and the 2 degree is the same, the difference between 2 degrees and 3 degrees. Right? There is only a 1 degree difference, and here is also 1 degree difference. Right? So the next example is a scores on a standardized test. Yeah, actually the 0 score do not represent no ability on the test, right? And also we can include a Likert scale when intervals are equal. Actually, the classification of the Likert scale is a common debate. So if we have any questions about the types of scale of measure about the Likert scale, maybe I'm gonna just give some directions for that question in any kinds of the quiz. And the last one is the ratio scale. This scale have numbers, and these numbers serves as a score which are equal distance between each other, and 0 as meaningful now. So the value 0 implies none of the variable. So examples of ratio scales are height, weight, time, scores on a school test, and dollar bill, something like that. So for example, how much dollars in your wallet? In this question, if you have 0, and it means nothing. Yeah, you don't have any money. So like this, 0 height is no length. And 0 scores on a school test means there is no correct answer. Yeah, so in this case, 0 has specific meaning. I mean the none of the variable. So this is the ratio scale. So we just talked about 4 different scale of measures: nominal, ordinal, interval, and ratio. And each scale has a specific characteristics. So you guys have to distinguish the difference among those 4 different scales of measures. So here is the classifying variables chart. Yeah, this is a really good flow chart for classifying the variables. So this chart will be a help to understand the difference between qualitative and quantitative, or discrete and continuous, or nominal, ordinal, interval, and ratio. Here, nominal, ordinal, and these are continuous, discrete, and interval, and ratio. And here is one more table. So this is the 4 scales of measures: nominal, ordinal, interval, and ratio. So for the nominal and ordinal, those 2 are always discrete variable. And intervals sometimes discrete and sometimes are continuous. Last, ratio is almost always continuous variable. Yeah. And we also needed to know what types of variables we have in study, specifically independent variable and dependent variable. The independent variable is typically an intervention or something that the researcher may be manipulating. It is often a cause that you are trying to quantify what type of cause or how much of cause that independent variable is having. The dependent variable as the outcome of interest. And this value probably changes in response to some intervention or independent variable. So this one is denoted as effect. So independent variable might be changing and we see what cause is happening. And the dependent variable is the effect that is being measured. So now, I do not want to know that in statistics, but we are very carefully use the word of cause. And we might try to cover the causal relationship, but at the very end of the semester, we will talk about a specific criteria that we need to determine if there are actually a cause from independent variable. And sometimes we have other variables which are confounding variable. This is influence the independent and dependent variable simultaneously. And these variables that co-occur with the independent variable. So a variable that you try to control or randomize away. So for example, we have 4 different kinds of the teaching method. A, B, C, and D. So this is our independent variable. And 10 students for each, just under the different teaching method. And then those students took a math test. And we got a different kinds of the test score from those 40 different students. So this is our dependent variable. But if we assume that for each teaching method, we just assign different teachers, teacher 1, 2, 3, and 4. In this case, it is really hard to know the difference from different teaching method or different teachers, right? So in this case, different teacher can be a confounding variable. So like this, confounding variable has to control out in our studies. So if we would like to know the effect of the different teaching method on the specific test, we have to control these kind of the confounding variable. So for example, we have to the same teacher for all different teaching method. So the only difference is the teaching method for those 40 students. So like this, confounding variable is always have to control out or randomize away. So I just bring some examples for the independent and dependent variable. So researchers would like to examine the impact of using an online courses versus an in-class courses on sexual violence awareness. So in this case, what is the independent variable? Yep, in this case, the class format is our independent variable, right? The independent variable that a researcher would like to manipulate is the class format. So some students assigned to online, right? And the other students assigned to in-class course. The next question is here. What is the dependent variable? Actually, the dependent variable is the effect that is being measured from different format. So in this specifically situation, yeah, the sexual violence awareness is our dependent variable. And here are the last question. What are potential confounding variables? So think about what are potential confounding variables might be in this example. Maybe we can assume that both class format have male and female student. So if we assign only males or only female students in both class, we can figure out the effect of the course format. However, if we have both the students in online course and in class course, it is really hard to know the effect from only different class format, right? So likewise, the distribution of the age also can be a potential confounding variable in this example. And here is one more example. The research question is here. Do females report more instances of sexual violence than males? So please stop the video and think about the answer for following questions. Then restart the video and check with me about the answer. So let's check with me. So in this example, what is the independent variable? Yep, the independent variable is gender, male or female. So specifically, this independent variable of gender has two different levels, right? Male and female. So we want to compare these two different groups. So what is the dependent variable? Dependent variable is the outcome of what is being measured or influenced by independent variable. So in this example, the number of instances of sexual violence, right? Incidences of sexual violence reported. Yep, this is our dependent variable. So as before, it is important to consider about what is the potential confounding variable. So for example, location or age can be a possible confounding variables. And you can consider other potential extraneous variable, That's good. So now we can apply this independent variable and dependent variable into your own research interest. So you guys just stop the video. Then you can think about what is a research question that you are interested in and identify the independent variable and dependent variable. And write up your research question, independent variable and dependent variables as an exercise. So if you would like to check about your own research question, independent variable and dependent variable, you can simply send an email to me or upload it in the discussion board. Then I'm gonna just check for your own research question and independent variable and dependent variable. The next one is the assessing variables. So choosing the correct variable is really important. So an operational definition is a thorough definition of exactly what you want to measure. So these variables needed to be valid, meaning the variable measures what you intended it to measure, and they need to be reliable, meaning they consistently measures what it is intended to measure. So the example is height. We define the height as a measure from a base of the feet to the top of the head reported in inches. So the valid measurement tool will be yardstick, rulers, or tape measure. These will be reliable if the same person was measuring each participant. So someone can measure more strictly or the other person cannot. So consistently measuring the height is important. And here is the invalid but still reliable measurement tool. Maybe scale. Actually, scale can consistently measure, but it is for the weight, right? Not for the height. Yeah. So scale has a reliable measure, but not valid one, right? Or the other one as a thermometer. Yeah, this is the tool for measuring the temperature reliably, but not valid for the height. Yeah, so you guys think about the valid and reliable. So what you intended it to measure, this is the valid or invalid one, and consistently measure as for the reliability things. And this is the last thing this video. So this is the brief introduction for the hypothesis testing. Hypothesis testing used inferential statistics to make conclusion about whether a relation between variables observed in a sample are expected to happen in the population. So there are different types of hypothesis testing procedures. So one is the experiment. This is a research design where participants are randomly assigned to a condition or a group of the independent variable. And the other one is the quasi-experiment. This is a research design where participants are not randomly assigned to a condition or a group of the independent variable, so like gender. But characteristics of participants across groups are compared. So here is our example about the gender, right? So we cannot assign gender to each person, right? So we can still compare those two different groups, male and female, but we could not assign. So in this case, you guys can use the quasi-experiment design. So back to the experimental design, we have two different design. Between group study or within group study. First, the between group study is one in which participants experience only one level of independent variables. Observations across level of the independent variables are from different group of participants. So back to the previous example about 4 different teaching method. Are you guys remembering that? Teaching method. A, B, C, and D. For each teaching method, 10 different students are assigned. It means that those 10 students are only A level of the teaching method. And those 10 students are only in the B teaching method. And those are only C, and those are for only D teaching method. So this is a really good example for the between group study. On the other hand, if participants experience all levels of the independent variable, observations across level of the independent variables are from the same participant. So like pre and post test measure is a really good example for the within group study. So for example, in this case, we have only one teaching method. This is really new things. New teaching method. So first, 10 students were assigned. So before the new teaching method, they're gonna just take a test. And they're gonna take a new teaching method class. And after the this course, those same 10 students took the same test, post test. And then compare those pre and post test. Actually, the same student experience all levels of the independent variable, pre and post, and experience the new teaching method. So this is the within group study. The last type of the research design is a correlation study. This is a type where variables are non-manipulated. So This is a research design where variables are not manipulated. The goal is to determine a relationship among variables as they are occur in nature. So in the correlation study, we simply observe the variables as they occurred in nature, and we want to determine a relationship among variables, but there is no control by researcher. This is the correlation study. Yeah, so this is the learning objective for today's lecture. And you can see that today different kinds of the examples or exercise in the canvas. So if you have any confusing point through the lecture, I fully recommend it to see the video again or use the discussion board if you have any question. Or you guys can freely contact me by email. Then let's see in the next video.